Recently, I came across a fascinating RC hobbyist project where an MPU6050 was used to create a head tracking device for an RC car. The camera was mounted on the car, and the experience of it racing across the grass was incredibly cool, giving a truly immersive feeling. Inspired by this, I thought about my own MPU6050 gyroscope and accelerometer module, which supports I-to-C communication, and my 50-to-pi experiment tray along with an Arduino UNO R4 WiFi. I decided to give it a shot and see if I could replicate a similar Arduino project, using the servo motors to create a pan-tilt mechanism for the camera. I'm excited to share with you the process I went through, which I've documented in this video. I hope you enjoy it. Here is a step-by-step breakdown of how I achieved this. First, I connected the servo motor wires of the pan-tilt mechanism to the Arduino UNO R4 WiFi. The red wire from the 3-pin connector was connected to the 5V pin of the Arduino for power. To facilitate this connection, I used a jumper wire to bring 5V to a breadboard, and the brown wire from the servo was connected to the GND through the breadboard. The orange wires were then connected to pins 9 and 10 of the Arduino. Initially, the video started with a connection on pin 11, but I found that pin 10 was closer to the center, so I switched to pin 10. The horizontal servo signal was connected to pin 10, while the vertical servo was connected to pin 9. Next, I inserted the MPU6050 pins into the breadboard and connected the VCC pin of the MPU6050 to the 3V pin of the Arduino, and the GND to the Arduino SGND. The SDA pin was connected to a 4, and the SCL to a 5. Initially, I made a mistake in the wiring, which led to incorrect data output. I even checked the MPU6050 token H header file for errors. Fortunately, I realized my mistake and reconnected the wires correctly. After that, everything worked fine, and I was able to retrieve the angle data from the X, Y, and Z axes using the getAngleX, getAngly, and getAngleZ functions, enhancing the DIY head tracking RC car with Z-axis control and Arduino networking. In my latest update to the DIY head tracking RC car project, I made a significant discovery that improved the user experience. I found that using the yaw angle from the Z-axis of the MPU6050 gyroscope to control the horizontal servo motor made the system more intuitive and user-friendly. I replaced the getAngly function with getAngleZ, and the results were impressive. The code was straightforward, and I managed to debug and implement the changes in just half an hour. This modification got me thinking, could I use an Arduino UNO R4 WiFi connected to an MPU6050 gyroscope to transmit data via Wi-Fi to another Arduino UNO R4 WiFi, which in turn controls its own connected servo motors? This setup would essentially allow me to create my own remote control system. I'm excited about the potential, and I can't wait to explore this idea further. Stay tuned for more updates as I continue to experiment and innovate with my DIY head tracking RC car project. Let's see where this journey takes us. This project was a fun and educational journey, and I'm thrilled to share my experience with you. Enjoy the video, and let's keep exploring the world of DIY projects and Arduino.